I'm doing two more numericals on connected motion. Let us begin with the first one. A 6 kg mass is suspended by a 2-meter long rope from a ceiling. A horizontal force of 50 Newton is applied at the midpoint of the rope. Find the angle the rope makes with the vertical in equilibrium. So we have a situation like this. Let us say this is a ceiling and this is say the 2-meter long rope. Right? A 6 kg mass is suspended over here. So mass over here is 6 kg initially. Right? Now this length is 2 meters. Right? So this is the mid. Let us say this is the midpoint. Length is 2 meters. This is 1 meter. This is 1 meter. At the midpoint, a force of 50 Newton is applied in the horizontal direction. A horizontal force. So a force is applied in this particular direction. And we have to find the angle the rope makes with the vertical. So when you apply horizontal force, we will have a situation like this. The rope will, the upper half of the rope will take a shape like this. The bottom half will remain the same position. We'll have 6 kg over here. Let us, just for sake of ease, call them point A, B, and let us say point C. So this is the position in which the rope will come, and we have to find the angle the rope makes with the vertical. So this is the rope, and if I look at this, this is the vertical. We have to find out this angle theta. Now if you look at it in a very simple point of view in terms of the various forces that are acting, let's look at what are the various forces that come into play. Obviously, this is one particular force acting in the downward direction, and we will call it 60 Newton, 6 kg mass, G is to be taken as 10. So there's a downward force of 60 Newton acting on this. Now, if you look at this particular part, the lower part is remaining in the same position. So there's no major change happening in the lower part. Yes, the tension is changing, but essentially it looks very, very similar. The major change that is happening is in this particular part. So let us say the tension in this particular rope is T. There is a horizontal force acting in this direction, 50 Newton. Right? So this is the second force which comes into play. In this particular part, the tension in the rope was taking care only of this 60 Newton force acting in the downward direction. So if I represent tension T over here, this tension was taking care of force of 60 Newton. Now, in this particular situation, this tension T in the rope is taking care of 50 Newton as well as 60 Newton. How is it doing? It is doing by generating two components. This particular tension will have two components. If I try to show it over here, if this is the tension T, it has two components. One a vertical component, one a horizontal component. If I can show it over here, this is the vertical component and this is the horizontal component. This vertical component will be T cos theta, and this will be T sin theta. This is T sin theta. This will be T cos theta. This is angle theta. Right? So what happens is the tension T breaks up into two components, T sin theta and T cos theta. And as you can very clearly see over here, if you look at the horizontal direction, right, T sin theta is the component in the horizontal direction. It is taking care of 50 Newton. They are in opposite direction. So T sin theta is equal to 50 Newton. Why are we rating them as equal? Because we have been asked find the angle the rope makes with the vertical in equilibrium. So this particular point B is in equilibrium. And when it is in equilibrium forces, all the horizontal forces will be equal, all the vertical forces will be equal. Horizontal forces T sin theta and 50 Newton, so they equal. The vertical forces T cos theta and 60 Newton. T cos theta is equal to 60 Newton. And there are no other forces. So I get these two equations. If I divide these two equations, I'll get sin theta upon cos theta is equal to 50 upon 60, that is 5 by 6. Right? Therefore, that will give me tan theta is equal to 5 by 6. And if I do theta is equal to tan inverse of 5 by 6. Right? Let me do that calculation quickly over here. So 5 divided by 6 will give me 0.833. So 6 will give me 0.8333 shift and 0.8333. 0.833 will give me 39.7. So theta will be 39.79, and that would be approximately 40 degrees. So this angle theta is 40 degrees. Let's move to the second question. A 70 kg person in sea is being lifted by a helicopter with a rope which can bear a maximum tension of 100 kg weight. With what maximum acceleration the helicopter should rise so that the rope may not break? Okay, so if this is the sea, and let us say this is the helicopter, right? This is the helicopter, and this is the rope, and this is picking up a person from here, right? The mass of the person is given as 70 kg. Mass is 70 kg. And the rope can bear a maximum load of 100 kg. This is going up, right? This is accelerating in the upward direction. So if I try to show the free body diagram of this particular situation, if this is the man, right, he's accelerating upwards with an acceleration A. The tension in the rope T is acting in the vertical direction, right? And the downward force is 70 kg. So 70 into 9.8 would be the force acting in the downward direction. T is naturally acting in the upward direction because the tension is created by this force acting in the downward direction. Now the maximum acceleration, now this tension, maximum value can be 100 kg weight. So we'll have to take this particular equation. The equation that we'll get is T minus mg is equal to ma. T is 100 kg weight, right? So T would be 100 minus mg is, so this will be of course 100 multiplied by 9.8 minus 17 to 9.8 is equal to 70 into A, right? So this will give me 30 into 9.8 is equal to 70 A, and I can calculate the acceleration as by doing a quick calculation. 30 multiplied by 9.8 divided by 70, 4.2 meter per second square. Okay, now let's stay with this question for a few more seconds. What is happening is when this helicopter goes up, the tension in the rope is there because the man is hanging onto it. If it tries to go faster, the tension in the rope will increase, but the maximum allowable tension is 100 kg weight. That is why we get this equation T minus mg, because T is acting in the upward direction and mg in the downward direction. And therefore, the maximum acceleration with which the helicopter should move up is 4.2 meter per second square. Thank you.